So this is a short video that I'm putting together to explain memory logic, and this little lesson will help you complete the sheet Logic Lab number 4. So the first thing we have to discuss here is this term called momentary contacts, and basically a momentary contact means that the contact is either open or closed in its normal state. However, when you act on that normal state, for example, you push that button down, okay, what happens to the closed contact? It becomes open. And what happens to the open contact? It actually becomes closed. So that state, S-T-A-T-E, that state changes, but only when you're acting upon it, only when you're pushing. So the question is because it's just a momentary state, how do we keep this equipment on? Imagine you were an operator, okay? So here you are, and you're going to be working in this location, and it's your job to push that button. How cost effective do you think it is to have that person there, stand there all day for an 8-hour time period, just pushing that button and holding that so that that machine stays on? Probably not going to be a very good industrial application. So in order to start a process and maintain a process and keep a process going, we're going to use a set of contacts called memory, and we're going to explore that both with the motor starters and also with the relay. So I've got a couple drawings here. One I've got labeled motor starter wiring up here, so notice in the circle here we use an M1 for motor starter, and down here I've got this contact drawn in with the arrow here, and that's our holding contact, or we're going to call it a memory. When we're dealing with a motor starter, we're going to look at screw terminal 13 and screw terminal 14. Those will be important to us later on, and so what we'll see is if we were to blow this up, we're going to have number 13 right here, and we're going to have number 14 right there. So that gives you a little bit of an idea of the numbers and the numbering system that we're going to use. And again, those are the manufacturer terminal numbers, so those are going to be true regardless of the type of equipment we're using, because remember, NEMA kind of standardizes all of that for us. Over here on the control relay, same situation, but we have a lot more options because we have several different open contacts. We could use any of those numbers, and you guys are obviously familiar with those. We've been using those all along, and so we're looking at just a simple open contact off that relay. So here's kind of what it's going to look roughly, and I tried to use the appropriate colors. Notice I've got purple, and the purple starts up here at A1. This is coming in from our inputs right up here, okay? And then we include this jumper right here. So this wire here comes all the way down, and it terminates on number 14 down here. So that jumper is going to be important for us anytime we're doing a motor starter. That's going to have to be installed so that we can maintain that motor starter and maintain that process. The same is going to be true over here on our control relay. I've got this jumper drawn over here on 2 to 3, just a short little wire, okay? And again, we've got power on 1 because we're going to use an open contact. So in this case we're using the contact 1 and 3. And what that contact's going to do is that provides a bypass so that when those momentary contacts open, we are going to maintain our control circuit. So upon energizing, we're gonna act on this green push button here. We're going to close that contact. M1 over here is going to energize, and once that energizes, this contact's going to close. And now, once this button returns to its open state, back up here, now we've got this new path for current to flow, and that's going to maintain our M1. Okay, so now, as long as things work properly, our M1 is going to continue to function until, notice what happens. I'm going to go ahead and act on one of these stop buttons over here, and so my stop button is going to open. So now my electron flow is going to stop right here. So my electrons are not going to get past that point, and what happens then is my motor starter now de-energizes. So this de-energizes, and so now this path right here has been eliminated, and I'm back in business again. I've got a new open contact, and so now my status is reset, and I'm going to begin over as soon as I act on my start button again. So a few things to keep in mind when we're looking at these drawings. Here's two drawings of two motor starters. This contact over here, we're going to discuss this at a later time. This is important, and this is always going to be drawn in a closed configuration, and that's called our overload contact. And we'll spend some time talking about that later. But again, here's our holding contact or our memory. Here's our holding contact or our memory. Notice the configurations. Here I've got stops. They're wired in series. And then down here we've got one stop, obviously in series, but then we have all of these right here, and those are all in parallel with each other. And down here at the bottom we have that holding contact or memory. Notice again here, these are in parallel also.